What do we got today, this Friday afternoon? We got warm up number one to start with. Finding the equation of a line that's perpendicular to this line and passing through this point. So, as was pointed out, there are two different versions. So I didn't ask for which one. I'll do them both for you and see what we can do. Okay, so to find the equation of a line, what we got to do is we got to find the slope. We need to find what m is, and we need also to find what what b is going to be if we do the y-intercept, or x1, y1 if we do that one, or when we do that one. Okay, so let's find the slope from this line here. How do we do that?
To find the slope, we need x2, no, y2 over x2 minus y1 over x1.
Well, not bad. Zoom is saying use the slope formula for this, and we could, but to use the slope formula, we also need 2 points.
Oh, yeah.
So we don't have
Yeah,
those.
we have to, we can't find like 4x1. No.
We could actually find 2 points. Let x equal 1 and solve for y. Let x equal 5 and solve for y, right? But I think with the 7, the numbers are a bit weird.
No,
So I'm gonna do it a different way.
Mm-hmm.
Okay. What I'm gonna do is I'm gonna switch this so that it looks like that. I'm gonna get y by itself. Okay. So finding the slope from our original line, I'm gonna move the 2x over. And so I get 6y is equal to minus 2x plus 7, like that. And to get y by itself, divide both sides by 6. So you get minus 2x over 6, like that. And then plus 7 over 6 as well. Remember, everything gets divided by 6. Okay. We are looking for slope, which is the number in front of the x here. So we can say at this point that the slope is minus 2 over 6. Okay, but recognize though 2 over 6 can be simplified. And so we get slope is minus 1 over 3. Okay, reduced is the official word, actually. Okay, so that's good. We get the slope of our original line. What we need now, though, we need the slope that's perpendicular to this. So, for a slope that's perpendicular, I think I heard it in class or something like it.
It's receptacle.
Yeah, from Zoom, I'm going to write it on the screen. The magic word there. Reciprocal is where you turn a fraction upside down. And that's true. That's one part of it. So if we turn 1 over 3 upside down, what do we get? Three over 1, which is just 3. And there's one other piece that we need. and that is the sign has to be opposite as well. Okay, so we have a minus there. That means we have a plus here for our new slope. That is the slope of our perpendicular line. See, slope of our perpendicular line like that. Okay, so from this and with the point that we have, we can get the slope point form right away. That's the nice one. Okay, so for the slope point, we got, as was said on Zoom, y minus y1, mx minus x1 like that. So we get y minus the 9, which is the y value here. The slope we figured out is plus 3. And then we got x minus 4. True? True. Now, if we wanted to find the slope intercept, we could actually do what we did last day. So you can go take a look at that. I'm going to show you this today. Because we have the slope point already, what we can do is multiply the 3 through, right, to get y by itself. Okay, so what's going to happen is we'll multiply the 3 through. So we get 3x minus 12. Don't have y by itself yet, almost. Got to get the 9 out of the way. Y is equal to minus 12 plus 9. Changes the sign. And so we get a final answer looking like 3x subtract 3. All right, so show of hands. Who got the first? Who did this version? No one? Went for the tough one? Okay. Who got this one? So you get plus 3? Well, oh, okay, you did the, so what do we got so far? We found the slope point form because it's the easy one. And then I went from here to the slope intercept. Okay, it's possible to get this one directly. Okay, so that's what I think you did there, right? Yeah, it should be the same. So I can do that here to show you. Okay, so I'll say slope intercept direct as opposed to going through the other one, the other style. Slope intercept direct. So what do we know? We do know our slope is still plus 3. That's not going to change. We do know the point that we're going through is 4, 9. And so the work looks like this. Y equals mx plus b direct. Okay, so the y value we put in is the 9. Slope is the 3. X is the 4, yeah. And then plus b is what we need, right? Well, we need m and b. We got m, we need b. And I think that still works out, because what's 3 times 4? 12, right? Looking for plus b. So now maybe this step is where it gets a little weird. What do you do from here? Okay, yeah, it is switch, but yeah, I gotta watch. So 9's going to that side. Okay, so it becomes minus 9. Plus 12 and plus b so far. See, 0 on that side. There's nothing left. So what'd you do next? Move B, okay. Over the equals sign, so we have this now. See, it's positive there, becomes negative. That's where some sign. Okay. I'm looking at this line here. I was told to move the 9 over, so I did. It is. Yeah, -9 and +12, that's true. Yeah. Well, let's just check. First of all, we can switch the order as long as we take the signs along, right? It's true. So what's 12 minus 9? 3. Okay, but notice minus B is equal to 3. So then how to get plus B, which is what we need? You can divide both sides by -1. Then you get -3. Final answer, just like we had. Y is equal to 3x minus 3. Slope intercept direct. Yeah. Okay. Good work for a Friday. Couple different styles of answers there. Okay. I got another little warm up for you. Really tiny. It goes back in time. Oh, okay. Yeah. So someone wants to see the question again. So I'll just do it from the start there. So here's the first page. Yeah. That'll come. Yeah. I'll show both. Oh, there's a few pages for this one. Okay. So that's the first page. The second page was this one. So we had to find the slope for it. Slope for what? Slope for the perpendicular line, right? Okay, and then there are different styles we could find. That's what this page is, the style page. So the question didn't say which one, so if that happens, choose the one you like. Okay, but this shows you how to convert from slope point to slope intercept. Let's multiply through, move everything over. And then the last page, which is going directly to that slope intercept style. Okay, same answer, 3x minus 3. Okay, here's the second warm up, going way back in time, but as I said, pretty tiny question compared to some of them you've seen recently. So I'll pause the video while you take a look at this. Yeah, okay. As I said, this one's pretty quick. Sounds like you have it already. Factorization, yeah. Prime factorization is the official language there. TION. Okay, for 200, what do you get? Or I'll put prime in brackets because there's a couple of ways to do this.
2 divided by 2.
Okay, 2 is part of it.
It's 100.
2 times 100, yeah.
And 2.
2 times 50, yeah. It's 2. It's 2. It's true. Yeah. 5 times 5 will do it there.
Thanks for, yeah.
We'll just leave it like that. It's true.
Divide by yeah.
Okay, good, beautiful, nice. What do you do with these now?
Now we
Good.
put all of them in a bracket and square roots.
Okay, Zoom says put them all in the square root. That's okay. Big square root to get them all in there. We got a 2 times 2 times 2, 5, 5. Okay. 2 times 2 times 2, 5, 5. And then the x3 is still in there, I guess. Okay. Not bad.
So two twos goes out.
Yeah. Zoom's remembering it well there. Good. 2 2s go out.
And 2 5 goes out as well.
2 5s go out. Yep. Right.
So
Class
we-
got it there. Those 2 2s turn into the 1 2.
Yeah.
Those
and
2
1
5s
5.
turn into the 1 5.
And bracket 2. In the square.
Yeah, under the square root. And we still got these x3, x to the 3 to
Yeah.
think about, but good so far.
So multiply them together. 3
Yep.
times 2, 6. 6 times 5, 30.
Yeah. No. 30 it is. And then 2 and an x cubed on the inside. Okay, not bad. The number is correct, 30 and then the root 2. What about this x cubed though?
Oh, that's what I want.
Yeah, good. From class, nice reminder that x cubed is the same as x times x times x, right?
Oh, yeah.
So just like, is it still on the screen? Yeah, just like all those prime factors can be written out. Same with the x's, those can be written out. And then, well, I can do the same trick. We get 30, trick, strategy. Not playing games here, all serious.
Oh, yeah. 2 x goes out. And
2 of the x's go out. Yeah?
And give just 1.
Yep. Zoom says
So,
gives 1 on the outside. Nicely said. That's true.
so 30x and square root 2x.
Yep. 30x. And what's left? Square root of 2x. With one of those. Yeah, good work. So there's a couple of people in class that remembered. Anyone kind of remembered it? Yoya, Deanna? Kind of? Which part did you forget? Or as soon as you saw it, you're like, oh yeah, ding. That's because that happens. I'm going to put my finger there. You tell me what to do. Yeah, that part's okay. Up to the getting that. Okay. So what happens is with the, see how it's a square root? We choose 2 numbers at a time. And what happens with the square root of those 2 numbers at a time, they turn into 1 number on the outside. Okay. So we turn 200 into all these numbers that you did, right? You and Zoom. There they all are. 2 numbers at a time turn to 1 number on the outside. 2 at a time turns to 1 on the outside. And what happens is those numbers, they all get multiplied. So boom, 3 times 2, 6, 5, 30. Okay. Now, these groups of 2 things, right? 2 numbers, same with 2 letters. So watch, x to the 3, and this was the first week, I think, so you might not have been here. Surprise, here it is. So, so x to the 3 means there are 1, 2, 3 x's all multiplied together. So it helps to write them all out side by side until you get used to it. Groups of two things again, right? Because it's a square root. Those two on the inside turn to one on the outside, multiplied together. Leftovers stay underneath. Okay. We'll do one more. And we'll do some questions from yesterday. That's probably good for this Friday afternoon. Okay, so you write that down. Oh yeah, so this will be square root stuff again. A little more involved. Simplify the following. Okay, good people, you ready? One last warm-up question. Same topic. Just because we haven't done it for a while, and I think it's a good one to try. Okay, so we got that. So I'll pause the video, give you a chance to try it. I'll check on the class here. Let's take a look at this. How do we approach this question? What do we have to do? Yeah, we can do prime factoring again for, well, I'll do the 27. What do we get?
Divide by 3.
3, yeah, we can do it right from here. 3 and 9.
And 3, 3.
3, 3, that's right. So we can rewrite this term so that it looks like what? Well,
Or be 7 times 3 and square.
that's right. A bunch of 3s there with the X on the inside, right? Yeah, it looks good. Okay. What next?
2, 3 goes up.
9 turns in, question from class, 9 turns into 3, 3. So they are. Yeah, okay, we can continue with this. So take, so what do we do? 2 3s are out, that's right. And we're left now with 7x. Oh, left with 7. The 3 is out. There it is. 7's there. What's left on the inside? 3x. Okay, that's good. So let's leave it there. As you can see, we'll catch up on the next page. Let's go to the next term. What do we got?
So 2 times 7 gives
2 times.
what, 21?
Oh, it will be 21. I'll do it on the next page when I, right?
Yeah, will be
Yeah.
21 square 3x.
Yeah. 25 times 3 for up here. Yeah, we'll just work on this one. Get it to the same spot, and then I'll turn the page. 5 times 5, indeed. Then 1 and 5, 1 and 5. Does you want to do that? Okay. Okay, we got that there. Beautiful, looks good. What next?
Bottom is square root.
2.
Two square root.
Well, it's 5 times 5. Oh, yeah, and the 3 there. That takes care of the 75, right? X is still there.
Yeah.
Okay, it's good. What
So
happens next?
2, 5 goes up.
Yeah, those 2 go out.
So
So
it
you
will
get
be 2 times 5
2 times 5, which is true.
and square root 3x.
Square root of 3x like that. That's right. We'll see what happens on the next page with those. Yeah, just bring that one down.
Yeah, because it's already prime stuff.
Yeah. Okay, and so I gave this question just to remind you about these square roots, right? How to add and subtract them. So let's go on to the next page now.
Next page will be 21 in square root 3x plus
Yep.
10 in square root 3x and minus 3 in square root 3.
Plus 10. And then just copying it down. Yep. It's like that.
Yeah.
And so what do we get?
21 plus 10 is 31 minus 5.
That's a 3 there, Hadil. So
Oh, minus
20.
5 minus 3. Yeah.
Okay, so that will be 31 if you want to do those 2 at a time. To do those 2 together. Giving a final answer of how much?
28
Yeah. 28,
in square 3x.
just like that.
Yeah.
Okay, not bad, not bad. Question? I see the, yeah, I see, yeah, got a question. Here's the first page again. Okay. Yeah, good. So what happens is, so watch this. If you had 20, you okay now? Okay, 21 x plus 10x, what do you get? Yeah, see? And it stays as x, right? Okay, so that's not x, it's a little more complicated, but that stays the same. Okay, in your head, you could say bananas if you want, right? 21 bananas plus 10 bananas. How many bananas? I just add them up, right? Stays the same. Over here, we got minus 3 root 3x. See? So that's the same as these, so they combine together. So now you just got 31 minus 3. What does that work out to be? 28. 28 what? 28 of these things. Final answer. Yeah, the inside has to be exactly the same. Otherwise, so it'd have to be the same in order to combine them. If they're different, they just don't combine. So watch, I'll just show you here. If you had, I guess this is mini warm up 4, but I'll just do it for you. Or actually, if you're watching this video later on, you can stop the video and try and solve this on your own. Okay, so the question is, let's say we do all the simplifying, right? 3 root 3x, 7 root 3x minus 4 root 3 equals what? Yeah, so stop the video if you want. Restart it, try it. Okay. Here's the answer. Which one's the solution? Which terms are the same? Clearly these ones, right? Same variable. So these ones will combine together. So you got 3 of that plus 7 of that, right? So how many do you have? Yep, you got 10 of that, root 3x. But look at this. It's a root 3, it's close, but there's no x on the inside, right? It's different. So that means finished. Your final answer will have 2 terms inside of it. No, because these aren't the same things. Okay, that's a root 3x. This is a root 3. So root 3x is different, not equal to root 3. So that means finished. They don't combine together. Okay. Now, they might try and trick you. Mini warm-up number 5. Let's see, another mini question. Let's say you had 7 root 3 plus 6 root 12 equals what? Pause the video if you like and try this. Okay. But if you want to start it again, then you have to simplify first. Okay, so you see that root 12 over there? That's pretty big. We can do something with that. And then what you do is you check the square roots afterwards to see if they are the same or not.
Yeah, I got it. Actually,
Okay, so what does the 12 turn into when you simplify it, like the last question?
3.
Yeah, 3 times 4. Now I'm going to write that down because that shows a slightly different way that we can solve this, okay? So first of all, I see that 4 is a square number, 2 times 2. So I'm going to write that square number first. Okay. And the 7 root 3 are just going to bring down. Equals. Okay, so we could do the prime factors like last time, get our groups of 2. But yeah, this way might be a bit faster sometimes if you see it. And also it's something you should know. Different method. So what we did is we split, and I think that's what we called it a million years ago when we were working on this topic. See, it's all 1 square root. When the terms inside are multiplied, you could split the square root so that the separate terms are now multiplied. And the beauty of doing it this way, when you see a square number, is that the square number actually has a value. What's the square root of 4? 4 is 2 times 2. So what's the square root of 4? No, taksim is multiply. 2 on its own, that's right. So it's not even divide. I had to memorize a few days ago. I worked at it. Oh, I forgot though. Throwing the sheet. So yeah, square root, we haven't talked about it. We don't, in Arabic at least. But we can say 2 taksim 2 is 4. 2 times 2 is 4. Okay. So back to math, serious math. 6 times 2. Yeah, thanks. And then root 3. The point is these numbers are multiplied together. Yes, we do get 12 square root of 3 there. That would be a disaster if you did 12 times 3 because disaster. Because watch, if you add 12 times 3 with a good set of brackets, brackets are okay. 12 times 3, 36. 12 times, it's okay. Now you know. 12 times root 3, yeah, done, finished. No, not 36. What the? Give me a heart attack. No. Oh, I see. Yeah, jumping around. Okay, so 12 times 3, yes. 36. Is it suitable for this question? No, not suitable because it's a square root instead. Okay, that's the message. What do we got? 7 square root 3, bring it down. 7 square root 3, bring it down. And you see, they tried to trick you in the beginning. Different, you don't add them. But now, oh, they're the same, right? And so these can combine together now. 7 of these things, 7 things plus 12 things. How many we got? 19 things. That's right. Okay. How's it look up there? Oh, looks good. Okay, so 19 root 3 like that. Okay, let's take a couple of minute break. And I'll put up some questions from yesterday's topic, show you a little bit about what's coming next, and that'll be it. Yeah? Yeah. Okay. Pause the video, stretch the legs. Serious math time on a Friday. This is what we got. Yesterday, we had to label triangles. How did we label them? Don't say with a pen. Okay, what words did we use to label the sides? Adjacent is one of them, that's right. A DJ. Adjacent, it means beside. And we just, in North American stylings, we wrote ADJ. What's another side? Another word. What's that? Oh, good. Yeah, hypotenuse. That's the official word from Mr. Pythagoras there. HYP. And what was the last side? Tangent is a word in this topic, but not the name of the third side. Opposite, yeah. I was going to say for tangent, it's a part of tangent. Top or bottom? The opposite side is the top of tangent or the bottom? I'll let you think about it. Okay, OPP for the opposite side. All right, what else do we need to know in order to label a triangle? Sign for the, I'm just going to say we need to know what angle we're looking at. I don't know if we used this sign for an angle yesterday. I just named it by the letter. I might update it today with that symbol. Looks like an L, right? Yeah. Okay, I didn't use it yesterday on purpose, I might add, but today. Okay. If I do, it's in the massive homework stuff. Then, so we want to label this triangle. What angle are we going to look at? I'm going to say Y, just because. Okay. Okay, we're going to look at angle Y. And we're going to label the triangle with adjacent, hypotenuse, opposite by referring to angle Y. Okay, so notice, nice circle there to show the angle we're talking about. It helps even though it's like, you know, kid-like in a way. Okay, so where do these 1, 2, 3 sides go? Help me out. We're given this is the angle. So which side of the triangle is the adjacent side? Top secret? Okay, which side is the hypotenuse then? Okay, you can't keep that secret. What's special about the hypotenuse? Longest word. So it is the longest side. HYP for the hypotenuse there. The 90 degrees points at it. Okay, so that one's done. The opposite side, the adjacent side, which one's which?
Y and 7 or Z, Y and Z.
Yeah, if you're in Canada, Zed.
Yeah. Y and Z.
Yeah. YZ is what?
Opposite.
No,
No,
actually.
no. It's
and
opposite is X and Z.
Okay.
Yeah, it's X and Z is opposite.
Yeah, X and Z there for the. Oh, you did. See, I got 4 continents, 2 ears. That's how it is. The so opposite there, good. And that means the last one, adjacent. Adjacent is that one there, yeah. Because the adjacent and the hypotenuse always make the angle that we're looking at. Okay, so that's special. Okay, so I think I got a second example. Oh yeah, I do. Just crazily drawn. All right, so there that is. The angle we're looking at is angle B, just because. Okay. So pointed out in class, angle B can be written with this symbol here, angle B. It's like a little L. Okay, so label the instructions are label the sides. Okay, good people. AC is what side? Same choices as last time. Opposite, hypotenuse, adjacent. Same sides, different order. Okay, so side AC, which one is that? What's that?
Opposite.
From class side hypotenuse, AC is over here. Opposite, yeah. That's what Zoom said. Good work, it is. BC, what's that one?
BC. It's a hypotenuse.
BC is the hypotenuse. Because the might not look like it, I guess it kind of does, but the 90 degrees points at it, right? So BC is the hypotenuse. All right, AB. The last one, of course.
Adjacent.
Yeah, that's the one. A DJ, right? Adjacent. So the adjacent, like all questions, and hypotenuse, they make the angle that we are using. Okay, so I'll just put there HYP because it is, OPP because it is, and then ADJ because it is. Okay, nice. How's that feel? Seeing that again. Is that all right? Yeah? Okay. We pointed out this yesterday. We are using ratios, if you remember, for the for doing some trig questions. So what is the, oh yeah, ratios are also called them fractions, right? So special ratios, special fractions. Sine is always, always, always what fraction? Sine always uses what sides of a triangle? Sine is always, always the opposite side divided by the, yep, by the hypotenuse there. Okay. And there's a little trick to help remember. You can see it. The first letters are written right in order. We had S for sine. We have O because we hit it first. It's on the top. And then H because it is on the bottom. Okay. Cosine. Same question. What are the sides that always, always combine together? What are the sides that make up cosine? Nice. It is adjacent, and it's divided by the hypotenuse. Yeah. And so what's the little trick for remembering this? Same. C for cosine. A for adjacent. H for hypotenuse. And the last one, tangent. Heard it earlier in the class. What are the sides that make this special fraction? It's true. The opposite side divided by the adjacent side. And the letters again, taking them down. T for tangent, O for the opposite, and then A for adjacent. So remember, the first letter is always on the first letter is actually for the name. Second letter is for the top. Third letter is for the bottom. Okay. It matters that opposite is on the top. That adjacent is on the top over there. Okay. Yeah, it's true. Okay, now, if you have this memorized, we got one, maybe two last questions for today. It's true. Sokotoa. That's how I say it. You can too. Here they are. Write the right sign of X. For this triangle here. X, Y, Z. And we'll say 15, 20, 25, if that works out on the screen there. It's not bad. So what are some steps to figure this out? We did it yesterday to remind, to get that part of the brain going again. First part is to label the sides like we just did earlier. Okay. And then we gotta select the sides that we need from SOHCAHTOA, and then simplify if need be. Okay, so let's label the sides. Let's get that done. Well, that's the angle we're looking at. So give it a circle. That means the 15 is what side? 1, 5, yeah. What's the label that goes on that side? Opposite X is going to be the 20. Yeah. So what's this side going to be then? What's the 15? No, we're looking for a name. When we say label the sides, we're talking about, is it the opposite side or is it the adjacent side or the hypotenuse? That's what the labeling means. And remember, it matters what angle we're looking at, right? Okay. So 15, yeah, that was the original question there. That's adjacent. 25, hypotenuse. Okay, perfect. Okay, so that takes care of the labeling part. Okay, and still the adjacent and hypotenuse make the angle that we're working with. Okay, Now, they're asking for a sine. Why? Just because. So go in here. Sine is going to come from, sine for S means we use O and H, right? So sine of the angle that we're working with, sine is going to be the opposite side for the O divided by HYP for the hypotenuse there, for the H. We got our numbers here. So what is the opposite side? We go back to our good work here. 20, right? 20 is the side that is opposite of angle X. So it goes. The hypotenuse, how long is it? 25, because they told you. That's what's there in the question. And so now, yeah, it's basically done. Simplify this if possible, right? What number goes into both of those? Yeah, 5 goes into both. Yeah, good work. It's true. And so what are we left with? 4/5 finishes our good work for this this question there. You got one more in you to finish off? No on a Friday? Yeah, okay. If you want one more, then stop the video and check this one again. Peter says no, it's not going to do it. Okay, then I'll do another one. One more. Let's make it faster than this one, okay? Okay, last one. Last. There it is officially. Find tangent tax. Oh. Something to think about. Tangent of A for this situation here. So that goes like that. We got A, call that C. C is usually at the right angle there. B like that. And we'll have the numbers 8, 12, and 13. I think those go together, if I remember correctly. What's that there, Peter? That's an 8, yeah. 2 circles. If I do it all, it just looks worse. Like you've seen this before, right? That's of. OF. It's got style, but unless I tell you, unless you're used to it, you'll never see it. What's that? Oh, you do? You got the answer? What is it? 3/2? Yeah, maybe. We'll check it out. 3/2. We'll put it down there at the bottom. What's the first thing? Yeah, officially it's label. So what's the first thing of the first thing? What do you do? Yeah, exactly. Just really driving that home. Circle the angle you're looking at for sure. Label the sides. That's hence the name. We'll do the easy one. HYP. You do the hard one, which is 12. What's 8? Labeling the sides. What's the 8? Yeah, that one. That's the hardest one to say. So what's it? What's 12 then? Yeah, opposite, right? Opposite. And I say a DJ for this. It's adjacent. Yeah, good. Okay. What next after we've labeled this? Now what do we do?
Wait, what's the opposite over?
We got those in there. Zoom, I heard something, but didn't get it. One more time.
What's over? Opposite over like 12 over 13.
Well, that's just it. We got to decide what sides we use. So we have to do this SOHCAHTOA part here. That's true. Sine would be with opposite and hypotenuse, but what's the question asking? Tangent. What do we use? Yeah, pay attention. It's not sine for this one. Oh, unless it's for your notes. Tangent uses what sides? Opposite over adjacent. Yeah. Okay, TOA, opposite over adjacent. So tangent of A is going to equal what over what? 12 over 8. That's true. But someone said it's 3 over 2. How can we get 3 over 2 from this? Oh, because 2 goes into both? That's true. This is the same as 6 over 4. And then one more time. 2 goes into both of those as well, right?
Yes, 3 over 2.
3 over 2, right. Yeah, 3 over 2. So final answer. Yeah. Write it. Don't write it like a chain like this. It's kind of a bad idea. But I'm just doing it because of real estate on the page here. Final answer there, down there at the bottom. Tangent of A is 3 over 2. Good people. That'll be it for this Friday. Watch for the test to come up on Teams later on. You have yourselves I guess you'll have a busy weekend. So I'll look forward to seeing on Monday.